Okay, can you hear me? Yes. Thank you, Anil. I'm Marcus Sabadello of Danube Tech. We are in Austria and now in our phase 4 of the program. We work on decentralized identifiers, which is something that hasn't been mentioned very much in the previous presentations. However, it's a technology that's being used by a lot of the companies represented here in the room. Decentralized identifiers is something that by itself is maybe not as shiny and as glamorous as, let's say, a digital wallet or a physical card, but it's nevertheless a very important foundational technical component that enables things like credentials and wallets. So what is this? Decentralized identifiers, or DIDs, are a type of identifier that has been standardized at the W3C. It's a type of digital address, basically, that can be used to identify and refer to individuals and organizations and things. So in some of the previous presentations where you've seen the credential model, where you have issuers and holders and verifiers of credentials, those are identified using this type of address, these DIDs. And this is a type of digital address that has a few useful properties. DIDs are designed to be cryptographically verifiable and persistent and resolvable. And that last part is the most important function of this technology, where my company focuses on that. And it means that if you have a DID, you can look up the corresponding technical metadata, which most importantly includes public keys, cryptographic public keys. So this is what's needed basically to verify credentials. It's needed as a basis for credentials and wallets. So you could say that DIDs are a little bit for credentials and wallets what domain names are for the web. It's a basic address that makes everything work. And my company, we built a product that's called a resolver, so a technical component that implements this process of resolving DIDs to their metadata. And what you see here in this diagram on the bottom of the screen is basically the model that you've also seen in other presentations, where you have a holder with a verifiable credential that they present to a verifier, and at that moment when it gets presented, one of the most important things the verifier has to do in order to be able to verify the credential is that they have to look up the appropriate public key that's needed to verify the signature on the credential. And that's where this DID resolution process comes in. That's what the resolver that our company is working on provides. You can see that on the top. And one of the interesting features of this technology is also that these identifiers, these DIDs, they can come from different jurisdictions and from different underlying technologies. They can come from web servers or blockchains or databases or other infrastructures. And the superpower of this technology in a way is that it solves a question that has been traditionally very important in identity management, which is where to obtain the public key in order to be able to verify something. And that's what we do. There is no video, unfortunately, for some reason. This is also an outdated version of the deck. But nevertheless, this is what we do. Like I said, by itself, this is not something that an end user would ever see, right? This is like you never see an IP address when you browse the web. In the same way, you would never see a DID when you exchange your credentials in your wallets. But it's a basic component that makes credentials and wallets and the trusted, secure exchange of data work. And so our product is this one thing that provides a very specific function in the technical stack, which is DID resolution, to solve this question of looking up the appropriate public keys to verify something. And associated with that are also a lot of potential other things that can be done. So we can detect certain security weaknesses, we can detect duplicate keys if certain identifiers or certain cryptographic features are considered insecure. Then a DID resolver can also be a component that finds such weaknesses or that enforces certain security policies, because this happens early in a verification step, right? So if you are a verifier, if you're a government agency, for example, and you verify a credential, then resolving and verifying the identifier behind it is one of the first things that happen, and is a point where certain policies can be enforced, and certain issues can be detected. And we do a lot of things around that. Of course, enterprise features, auditing, monitoring, logging, analytics, and statistics. And one last thing, I will say one thing that has become quite important in the last few months, or interesting feature related to credentials and related to DIDs, is also to try and link these new technologies to some existing infrastructure, to some existing trust mechanisms. So technology like this, DIDs and the corresponding resolver, can not only verify the certain technical integrity and cryptographic information, but it's also able to, for example, check if a certain identifier can be linked to a trusted X509 certificate, or if it can be linked to a trusted domain name that's already known and trusted. So we see a lot of interest in that, also linking this infrastructure to something that exists already. And that's what we do, DIDs and DID resolution. Oh, here's the video. It was supposed to be on the other slide, but
I think we need to move to the questions at
yeah.
this point in time. And Marcus has moved upstairs, so you can actually get the full experience from him upstairs as well.
Yeah.
Can I ask you a question about how you find the different public keys? Are you linking to a series of registries, or how does that mechanically work?
Yeah, so like I said, there are these different types of DIDs, and a resolver is able to process these different types of DIDs. And how they work behind the scenes is very different. So sometimes there's a blockchain behind that. Now to resolve that, you have to go to that blockchain and look up the data there. Sometimes there's a web server, so you have to download some files from the web server. But sometimes it's also just more of a virtual process, where the DID is a little bit like a virtual data structure, where you don't necessarily have to go and download the data, but you can construct it from some information that you may already have. So how this works behind the scenes is very diverse, but the value is that there's this abstraction layer, right? That there's always the DID, and then as a result, there's always the cryptographic and other technical metadata associated with it.
What can you say about crypto agility and post-quantum safe crypto, especially with all the uncertainty with existing and upcoming algorithms? What's the ability to negotiate and change signature schemes and that kind of thing?
Yeah, so this technology, DIDs, is completely agnostic to that. It works with all kinds of different cryptographic primitives and key types. It provides, as I said, this basic function to resolve an identifier to the metadata, but that can also be, in the future, hopefully, quantum-proof keys, and the data model and the process is fully extensible. So if today we have DIDs maybe using RSA, and in the future we have DIDs using other cryptography, that is not a problem, and that is also, I would argue, one of the values that this technology brings, because you can swap out these pieces, but you don't have to replace the whole layer behind that. And one of the functions that our product here, the DID resolver, can also provide is you can set policies of which kind of cryptographic keys, for example, should be allowed or not allowed. So you could say that you don't want to support or don't want to allow any DIDs that use old RSA keys or weak RSA keys, then this will already be blocked at the resolver level before you move ahead further in the verification process.
I wonder if you could speak a little bit about how you see key management evolving in the future, so that it's not so dependent upon the human being for the key presentation.
So it's not
dependent on the people to be able to present their private keys in a way that exposes them to being intercepted.
Sorry, can you repeat it?
My question is how do you see key presentation and key management evolving in the future? Do you think that there's a solution on the horizon where key management will be automated and it won't require as much intervention from the user?
Key management. I think it's mostly a concern of the wallet and the place where the private keys are stored on this layer so deeds are controlled by private keys, yes, but when we resolve the deeds, then of course the information that's publicly visible is only public keys. But nevertheless, you're right that the deeds are controlled by private keys, so you do have this question of key management. One thing I can say about it is that the deeds are designed to be persistent identifiers where the associated technical metadata can be updated over time without having to change the identifier itself. So it's possible to rotate the keys, to update the keys behind the deed without having to create a new deed. So this creates persistent, long-lasting identifiers potentially that survive also key rotation and even switching to a new key type, right? So you could have a deed that was created using an RSA key to stay with the same example, but in the future could be updated to use quantum proof keys without having to change the deed. And there are even mechanisms built in for multi-sig and smart contracts and things like that. So this is again something that's extensible. There's no requirement in this technology that there has to be just one key, and if you lose that, it's automatically all gone. So it's possible to build in rotation and multi-sig and updates and recovery into the system.
Thank you very much, Marcus.
Thank you.